Hey everyone, my name is Harry Tormey. I'm the CTO of StepChange.work. We make your databases and applications faster. And today I'm talking with Luke Demi, who is going to be telling us a story about how he took Clubhouse from 10K to 10 million users by scaling their backend. So, Luke, why don't you tell us a little bit about you and your background?
Sure. Yeah. Like Harry said, my name is Luke. I was part of the team that helped scale Clubhouse pretty rapidly during the late 2020s and 2021s. Before Clubhouse, I spent time at Clubhouse and DoorDash and Coinbase. Coinbase was another particularly fun experience. We got to scale through the 2017, 2018 bull runs, which was also a whole bunch of fun scaling and database work. But yeah, Clubhouse was also a pretty exciting journey. We got to scale really rapidly, and I was part of a very small team that got to do that.
Yeah, I mean, you've been through some real wars, Luke. I mean, Coinbase during a bull run when you had those massive spikes in traffic is something to behold. But tell me a little bit, like, so if I understand, what you've told me about Clubhouse, they started on Heroku. So tell me a little bit about like how you found Clubhouse when you kind of joined.
Yeah, someone I worked with at Coinbase, Mo, he was early Twitter, early Coinbase, and then uh, controversially employee two at Clubhouse. Kind of joking, but they were hired within days of each other. But they were hired at the same. Or Mo was hired and was the backend engineer at Clubhouse, and Mo reached out to me when they were starting to have scaling issues on Heroku, and it was clear that Heroku was not going to be a long-term solution for them. There were a lot of reasons for that. For example, like Heroku was every time you deployed, you had downtime, and they were kind of going on the model of deploying, you know, 15 times a day. So like 15 micro outages in a day was obviously ridiculous, but that more than anything, it was the database that was kind of leading to a lot of problems. It wasn't really the normal Postgres. I actually don't remember a lot about the database other than that we didn't have the visibility we wanted and we weren't able to scale it really at all beyond they have these like tiers you can go into. And I guess my biggest takeaway from Heroku was that Salesforce just didn't care about it much as a product, and it didn't feel like they were investing in it. And obviously, if the platform is going to be growing, and if they wanted to be able to invite more people than they were, and kind of really get to a place with instead of 10,000 users, 10 million users, it was clearly not going to be Heroku. So I was brought in to lead the transition to AWS.
Yeah, and now Heroku back in the day was definitely one of those platforms that make it really easy to get started and to iterate on, which is awesome. But like taking a step back from Heroku and just looking at like Postgres as a product, when does Postgres start to break? And can you give some sort of flavors of the types of things that are likely to start causing problems first with it, Luke? I'd love to kind of understand that a little bit better.
Yeah, just at a very, very high level, Postgres has resource limitations like any database or server. And Postgres, especially in Heroku, kind of you have one, and maybe you have read replicas. But if you're mostly just going to hit saturation of either CPU. Queries take compute to serialize, deserialize, all the different things that are needed in the query engine. And that tends to be where people run into issues first, is just compute limits. So you scale up to bigger computers. Um, Memory is another classic one. You need to have memory for caches. You need to have memory, like working memory for each query. You need to be able to store all of your indexes in memory, and indexes can get very large depending on your data size. Those are kind of the classic things, and those are the things we ran into with Heroku. But of course, there are lots of further down the road things with Postgres that are crazy. But the biggest one is connection limit or connection memory. And connections take a lot of memory in Postgres, but really creating connections in a burst with Postgres is particularly bad. And it was something that was a major theme of some of our challenges with Postgres throughout my time at Clubhouse.
And I think this is a great segue into maybe describing the sort of back-end architecture and the properties of something like Clubhouse. Because, I'd imagine with the rooms and stuff and the way that people would just like all mass onto a room, that presented some interesting challenges. So why don't we, before we get into the transition to AWS, talk about like what Clubhouse looked like from a back-end architecture point of view and the challenges that presented for scaling up a Postgres database.
Yeah, at a high level, there were Clubhouse is a real-time application,
Yeah.
and we, at a very, very core level, Clubhouse was a list of rooms, like a feed you would get, just like Facebook or whatever. But this is a very fluid feed. It's happening live. And the way we would generate that feed is by essentially taking, first we get a list. You call get feed or refresh your feed or load the app. You would get a list. We would get a list of every single room that existed, every channel. And we would try to find a way to get the channels that were most interesting to you at the top. And that, I won't get into the performance characteristics of that yet, but that's basically what we were doing. And that was probably our most expensive endpoint by far, is just getting a list of different channels. So get feed. And that would be, generally speaking, about 50 to 70% of our resource consumption on a day-to-day basis. Get channel. So if you're in a channel and you're hearing audio, that would tend to be about 25% of our remaining CPU, or broadly speaking, that was where we had to put our energy. Because when you're getting a feed, you're basically downloading a whole bunch of information about all of the state of the network, all the channels that exist, all the people you follow, where they all are, where these interactions meet, and any other growth hacking that was necessary to make sure you found a room that was interesting to you based on previous rooms or rooms you've interacted with a lot. We did that all live on the fly.
Wow.
Getting a channel, for example, is another challenging thing because we'd allow up to 8,000 people in a channel. At the time, it was only 5,000. And every time you joined a channel, you would have to fetch everybody in the channel, information about them. And what people would do, a big part of what Clubhouse was, is that people would refresh the channel by dragging down from the top, and it would refresh all the profile pictures of people. And getting all the participants in a channel was also expensive because we had a very important, basically a join table called presence that joined the people who exist in the platform, the users, and the channels that they're in. And that was a very, very expensive.
I was about to ask you, is that the most expensive query or one of the top
Yeah.
queries? Like,
Mhm.
okay.
The
And was
presence
that,
table was consistently the one that mattered the most, the presence table. And any queries on presence were very expensive and very, 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 very challenging to cache.
yeah,
So
I was about to say, was it like expensive from both a CPU and a memory kind of point of view? What?
no, it's all compute really. Like is where we felt our real pain. Memory is always important, but memory is not what would take you down or what you would like experience that would cause major issues. Like you always had to be aware of memory, and especially as you're scaling, you need to be able to think about compute. Like you have to be able to think about compute, or you have to be able to think about memory. But compute is what is. You go from having 10,000 people on a day, like present on the platform, and then a big person comes on. And a thing I forgot to mention is we're also real time feed. So anytime somebody you follow joins a room, we would send notifications to every follower of that person.
Whoa.
So if a large person, like for example, the co-founders had the most followers. So basically every single person who joined the platform would follow both co-founders, and they would have millions, however many users there are, they would have that many people following them. So you would send that many notifications all at one time. And I should turn that off for the
As well.
I'll figure out how to do that. Put a
I
note.
oh man, yeah, I know.
Um, and so you basically send 10 million,
Yeah, Paul would
50
let us
million
know.
notifications.
Okay, I think that's a good overview of the architecture and like some of the challenging queries. So talk me through like the transition. Like, did you do it all at once in stages? Like, and how and what kind of things did you consider with AWS? Were you looking at RDS or did you go immediately to Aurora? Tell me a little bit about that, Luke, and how that transition was planned and orchestrated.
Yeah, so it was like October. The dates matter, but like it was October 10th where I got reached out to on Twitter, and I was like, well, I have a job, but obviously. I got a little excited, and I think within a few weeks I was just delving into just looking at the platform and the problems, and we're trying to decide how quickly we needed to move to AWS. And it became clear that this platform is just not going to work for a variety of reasons. There weren't a lot of really good band-aids we could put in place on Heroku. So when evaluating AWS, I'm a huge fan of AWS. I worked with AWS at all my companies I've ever worked at, really. And at Coinbase specifically, we had a lot of RDS issues, just using vanilla RDS Postgres. So I chose very strongly that my experiences with read replicas would be a perfect fit for Clubhouse from the Coinbase years. The ability to be able to auto scale read replicas up to, I think it was 15 or 60 at the time. I don't know what they're at now. For a very read heavy workload just makes sense.
Well, can I
And
pause you a second? 'Cause there's some interesting things. So you mentioned that you had some problems in the past with RDS. Did I hear that correctly? Can you
mhm.
go into that a little bit more and just kind of explain, like imagine a lot of the people who are watching this haven't dealt with the epic scale that you have, right? So tell me, why does one choose RDS versus Aurora or vice versa? Like, what are some kind of things that you would like say to someone who is sort of like, Luke in 2024 that was contemplating building something like this? Can you explain that a little bit more?
I don't know that it's necessarily that I had issues with RDS, but I saw the limitations of RDS.
Well, yeah, the limitations rather than the issues. Sorry, I beg
Yeah,
your
yeah.
pardon.
And I think the biggest factor is just going to be that it is servers. They're really, really clear cut servers that have all the problems associated with the management of the bin log, like whatever it is it's much more like read replicas have much higher latency. It's harder to add a lot of read replicas. It's expensive to add a lot of read replicas. The management, it's clearly not a first class thing within AWS. AWS has invested a lot more in Aurora, which is designed with like all types of little layers that are designed for scalability and flexibility. And also from a performance monitoring perspective, Aurora has a lot of that built in, like a lot of really good performance analytics built into the platform that give you down to the second granularity of exactly where compute time is being spent in the platform. And that's just like insanely valuable data we would have. Being able to see exactly what's happening at every second, tick, 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 and it's built into the engine. Anyway, all that to say, I wouldn't say it's as much RDS being bad. It's that it was last generation. And Aurora is clearly next generation, clearly has a lot of features that we needed to be able to really like,
Yeah, and so you'd say
yeah,
like, okay, so like the separation of compute and storage, like would be a factor, like the observability, like and like that
yeah,
fine
sure.
grained ability to debug. Okay, okay. So continue on, like, when tell me a little bit about the transition from Heroku to Aurora.
Yeah, so like I said, I had another job. So I was trying to like do this part time, and it was clear that this is fun. Like, I'm making consulting money. But I didn't have a lot of time, but the growing pains continued. And it became clear that Clubhouse was becoming a big thing. And we were doubling every week and a half. So every week and a half, the platform was doubling in size in terms of like
Wow.
weekly active users. And so what started as like 5 or 10,000 when I got involved was quickly in that you know, like we're at 50,000, and every problem we experienced was happening on an even bigger scale. And the urgency became a much bigger issue. So I put together what ended up being the permanent platform, which I had no idea would be the case of how this is outside of scope, but like how we use Code Pipeline to build the Docker images for the app, deploy it in a nice way across Amazon ECS. We were using Fargate at the time, and I thought all these technologies were really nice and perfect fitting and a nice way to clone Heroku. We actually migrated the compute first. So we chose to do that in December. So I basically made it through Thanksgiving, and the platform was growing so fast that we really didn't have a choice. We went way earlier than we wanted to before things were ready, and we migrated in December. Wait, let me check my dates here.
And what did migrating look like? Was it just like, hey, we've changed, we've moved the data across and we're now pointing at like Aurora and Bob's your uncle, or was there kind of a phase change? Uh,
Yeah, I'll tell you. Hold on, let me just October. yeah, I think it was, I don't have it written here, but the process for migrating for compute was very easy. We had, I think I had moved us to Cloudflare at the time, and Cloudflare has really nice tools. And we were just migrating compute and not any of the state. It's very, very easy. You migrate 1% of traffic. Does that 1% of traffic look the same as the other 99? And then you just flip it all over, and now you're deploying on there. And for example, we'd had our development environments on there for probably a month, and and then by the time we migrated everything over, we were pretty comfortable with the way deployments worked and making sure we were doing blue-green deploys. We could do a phased rollout, like 10% at a time with rollback buttons, and a lot of really nice convenience features for us. But we didn't migrate any of the state. And at the time, we were using Redis Labs for Redis. We were using Heroku for Postgres. The actual migration of the databases is significantly more challenging. Every database migration I've ever done is scary, because to do a proper database migration, you need to do one of two things. One is spend a long time thinking about how to do it live and basically build in dual writes and flip casually. Or if you're in a rush, you just take downtime, dump, restore. And we did the dump restore. So we were like, we're growing too fast. We don't have time to do the dual write, song and dance. Waited to our lowest traffic point, took the site down, dumped the DB, restored the DB, counted all the rows, did a bunch of sanity checks, pointed the app at the Aurora database, and turned it back on. And that's it. Like, it's really nothing too crazy.
No, I mean, that sounds awesome. And so when you turned it back on, like, did everything like work totally hunky dory? Was there issues? And then, yeah,
Yeah,
I'm just kind of curious.
it was fine. I
And so,
mean,
so when did you get
it's
the
the
problem?
days after that you start to notice every little edge case, but like everything worked fine. You make sure, and
What?
if you're relatively confident, you're doing like little checks along the way. Like you're doing your dev environment multiple times in a row. You're making sure all your users are created correctly. Like new rows are being created. Like there's all types of little tiny things that can bite you. That would bite us in the dev environments. By the time we got to prod, I felt like I had it pretty down. It was
Yeah,
really my big,
so
yeah.
Aurora isn't actually open source Postgres, right? Like it's Postgres compatible. Is there any kind of edge cases that people should know coming from, like, say, a vanilla Postgres managed service over to something like Aurora? Like, what were kind of some like gotchas or weird things that maybe weren't a big deal, but like are things that people should be aware of, if there's any of those, Luke?
I would really, first of all, say almost nobody's using open source Postgres in the wild. Like people are
Ah,
using different flavors of Postgres that have been modified and have all types of layers on top of them. Like if you're using crunchy data or something, yes, at the core it might be the open source, but at the end of the day, there's so many wrappers and layers. And we would run into a lot of things where when we were working with outside consultants, they would say, like, we actually don't know what's going on with this because it's Aurora. Like, you need to talk to AWS. It turns out that AWS is very responsive. If you complain loudly enough and you pay them enough money, they will dig really deep. And I would just say, like, you as someone managing a database should probably never be getting into the engine. Like, there are experts for a reason at getting into the real weeds of things. You're responsible for your application. Like I feel that as developers, we're responsible for our own application logic and making sure we're taking care of the database. Like if it's a car, we're not doing something really. If we're a race car driver, right? Like we're moving around the track, but we're not necessarily doing the aerodynamics of it. Like sometimes you do have to bring in deeper experts, or you're probably wasting your time. You can't
mhm.
go really crazy deep into domains, in my opinion. Like even like if you're looking at the source code of Postgres, I'd challenge that it's not
There's
something you should be
something that's
doing.
kind of gone wrong. But okay, so like you did your basically fast dump restore, things back up and running. How did you project out what was going to break next? Because I know from talking to you, Luke, that it wasn't all smooth sailing. And like, I guess I'm really curious about like the points at which Aurora broke down, and if there's any sort of insights you gleaned from working with AWS customer support that could be useful to other people watching this going through a similar journey. Like, I'd be kind of curious to hear about that.
Yeah, fun. So we migrated to Aurora, and like I said, we got these 15 replicas. There's 16 total servers, and we can make them really, really big. And we did. We just kind of scaled it all the way up. and we focused on everything else that was breaking. So like I said, we were doubling every week and a half, and it kind of, we actually didn't have to think about the database for a couple doublings. So we were able to focus on Redis, different application tier scaling issues. Definitely did a lot of work on Postgres connections, which I could talk about.
Oh yeah.
But the biggest thing was that we eventually did come back around to being the database. And I don't know that I really have a lot of like, I complained a lot about Aurora for a whole long time. In retrospect, I think they probably weren't fair complaints. Aurora did serve us pretty well,
You got to
and
show the
we were
TNT.
just
You
pushing
can't,
every limit.
you can't tease with the complaints. I mean, like we need at least a then and now. Like, what were you complaining about, and what do you think is not
Oh, I
reasonable about
think
it?
so. There's this tab of Aurora called Performance Insights,
Yeah.
and it shows that per second granularity, what's happening on the computer. And we could not see certain queries in it. We were
Oh,
really
okay.
confused. And it meant that we had to write our own, we had to use like a kind of hybrid of PG Analyze and our own home rolled stuff to be able to find some of the queries that were actually taking time. So like what they showed was just not summing up.
And is that a sampling
It
issue
turned
or?
out that it was
Okay.
because our queries had very large inquiries, very large numbers of user IDs or inquiries, because we'd want to see you follow 50 people or you follow 500, 5,000 people. We'd want to know what rooms are the people that you know in. So we're querying the presence table with all these user IDs. And because those user IDs are different, the queries were different. And so
Hmm.
it would only show each one of those as one query. So it couldn't aggregate them. That's an example of something that drove us nuts in the moment, but it didn't, it's hard to, I think they ended up fixing that. And also we found ways to get around that style of inquiry that made it easier to
And why
aggregate.
did that not show up in their performance logs? Was that a sampling issue, or is it just a straight up
Like
bug
I
in
said,
there?
so like if I'm doing an inquiry with 500 or 5,000 users and you're doing an inquiry with
Yeah.
4,999 users, they're different sets of users. And they
Ah.
didn't have a way to aggregate all the different queries that were exactly the same query, very expensive query, but had different sets of ins,
Oh, so it was like
different
that
sets of
different
IDs
user
in the ins.
IDs that basically didn't do that. And so you just had to put application level logging or like a higher level
Yep.
logging to kind of catch that part. Oh man, okay, that makes total sense. That makes total sense. Um, so, kind of before we get into where it did break again, right, like with the doubling, tell us a little bit about like connections and why they're expensive and what kind of things that you did to kind of mitigate those issues with
Sure.
Postgres, because I think that's
Yeah,
a
I
very
probably can't speak to why they're expensive. It's a good question. They just are. And Postgres in general, it's not designed. It's not designed for um, rocking the boat. I don't know really how to describe this. Like you could have Postgres running at 50% CPU, and then you could see a surge in traffic that brings you up another 10%, and Postgres can freak out. At least Aurora would, and it would usually freak out in ways that were we dealt with all types of weird, spooky issues. Like one of them was this thing called buffer content locks.
Oh,
Where's a
what's
buffer
it sounds
content
it
lock?
sounds sexy. Yeah. What is a buffer content lock?
And we never found out really. Like we spent hours and hours and hours with AWS, just hours. And the best way that I actually forget the exact explanation we ended up getting, but what would happen is we'd see a surge of traffic and we'd see a surge of buffer content locks. And it would send our traffic up to like our compute graph would go past 100% to like 500%. And it would just stay there with these big blue lines for buffer content locks. And it would get stuck. And the only way we could fix it was go in and delete manually queries inside of Postgres. I forget which ones we had to delete. Um, and I don't think they were our queries. I think they were like background jobs or some weird thing, some background thing. I wish I could speak to this better. I don't have access to all the support cases back in the day, but it would drive us nuts. And the only way we could do it is I ended up just writing a script that would just sit there and look for anomalous looking queries. And if it saw them and we saw that the performance was degraded, we'd just delete them and it would bring us back. It was a terrible way to live your life, but you end up writing a lot of those type of little scripts that check three different places. And if they see three things wrong at the same time, they do something very disruptive, but much less disruptive than being down.
Oh, okay. And
But
like,
anyways, good.
continue. No, continue on.
Connections are a particular. I got sidetracked talking about how Postgres can be a little bit sensitive at times to burst of load. But the biggest burst of load you can have is the creation of a lot of connections.
Mm-hmm.
And that was the case for us. Anytime you created 10% more connections that existed, and then you started using them too, you would basically cause potential for major issues with Postgres, especially if you're already well loaded, and then you add and use a bunch of connections. So that's really, really challenging if you are a Django app. So Django apps are particularly frustrating because you have to run clones of the process. So you run like on a server that has like 8 cores, people might run like 16 Django processes. Obviously, each of those uses a bunch of memory too, which is annoying, but they all want their own connection to Postgres. So if you were to do a blue-green deploy and double your number of connections from, let's say you just had one server and you double it, so 16 to 32, you're doubling your number of connections, big problem. So obviously what everyone does is they put poolers in the middle, and you can do different types of poolers. You can do like session level, transaction level. And we immediately went to using poolers. We just put PG Bouncer in the middle. But it's a delicate dance because let's say you put the poolers on the host themselves. So you go take it from 16 down to 1, or maybe there's a bunch of queries. You go from 16 to 2, and maybe you max out the total number of connections from each server to 5. You'll still use 5 if you have a query slowback. You'll still create a bunch of connections, or sometimes there's a little bit of a balancing act, like what's the max number of connections per server. But let's say in a worst case scenario, 10 servers come up, each of them needs 5 connections, you're creating 50 connections down to the server. It can still blow up Postgres. We dealt with this nonstop. So we solved this issue in 2 major different ways. Mm-hmm. One of the other ways you could get around this would be centralized load balancers. So you could have PG Bouncer in the middle that's completely absent of your app servers. It makes a lot of sense. It would be a really, really good idea. Except for the fact that it doesn't work with Postgres Aurora, RDS Aurora. The reason why is because the way the readers work in RDS Aurora is that it's actually DNS round robin. It's a CNAME round robin. And it's not round robin like every single query, it gives a different result. That's not how DNS works. They just change it every TTL. They change the reader. So if you have a bunch of new connections come up at the same time, they all go to the same one. So what would happen is we'd have servers come up and all of them would go to one reader and take that reader down. So it's like this really weird song and dance we'd have to do with the centralized bouncers. And I think that we tried writing scripts to try to like fetch those IPs, manually put them in. It was super janky and it had a lot of like, I forget the exact issues. But what we ended up doing that was pretty clever, we did 2 things. One is we picked the biggest app servers we could possibly find. So we just got the biggest servers money could buy. Not actually, but like the biggest off-the-shelf ones that we could get a bunch of that would have 96 cores on them. So then we would run 144 Django processes. And then there would be a PG Bouncer on the server itself. So that means out of all of those, maybe you get it down to like 3 connections, 5 connections. Instead of needing, in a case where maybe you have 1,000 different Fargate instances, which is what we had where there's 8 cores, if you're going to 96 cores, that's like 24 times fewer. So you can basically go from being at 1,000 different PG Bouncers connecting to Postgres down to 24. So that was one of our big solutions. So every single app server with all these 144 Django instances would all have a bunch of poolers. We had a custom Redis pooler. You have like every single service you use, you need a pooler. And by the way, running that many processes on a big box, there's like 1 billion different limits you run into, like DNS poolers. You need everything. You need to check you run into every single thing that you can run into. But the second thing we did is we used something called RDS Proxy, which is something that's really, really nice that I'm sure is a lot better now. But we got early access to that when it was still rolling out because we complained so much about these connection issues and the CNAMing. And what it allowed us to do is, so it's basically Amazon's version of a managed PG Bouncer. It
Yeah.
wasn't using PG Balancer, something else under the hood. But its problem was it was only session level balancing. So it wouldn't actually limit your number of connections. So we'd still max out our connections. So what we did is we put PG Balancer on top of that, on the actual host, and then we sent it to an RDS proxy, which then did the load balancing across all the servers and gave us controls at 2 different levels. And that was clean, and that worked really well. And that's how we got around the connection issues.
Well, there's some really golden nuggets in here, Luke, for people who are like coming on to Aurora and dealing with this. Like, I didn't know about the load balancer not working with Aurora, so that's like news for me. Amongst many other kind of details that you mentioned, I suppose before we move back to the actual scaling issue, um, Clubhouse is a Django shop. Django, were you guys using an ORM, or like tell me a little bit more from an application perspective if there was any problems that you ran into with Postgres and like, the way that the developers were working with it?
Yeah, I mean, at the end of the day, we were just using the Django RM. I don't
Yeah.
remember. Is there a name for it?
I don't even
It's just the
remember. I just
Django.
it's the Django ORM. Like there's a way that you do.
Psycho PG, right? Like
Yeah, I
it's
know. I
all.
mean, yeah, there's another interview that I'm going to be doing with Anant at Nextdoor, and like they ran into problems with their ORM, and like I view every ORM you always run into from an application developer's perspective.
Yeah. But we used whatever came with Django.
Yeah, so but
Yeah.
they had to break it out. And this is kind of a common pattern that I've seen
Mhm.
is like as you hit scale, like you sometimes need to kind of break out different API queries to kind of work around like stuff like that. Was there any issues that came out from the ORM with Clubhouse, or was it kind of
No, we never had ORM issues. Occasionally, we would rewrite queries raw, but we never. And this would be a better question for maybe one of the people who was doing like the actual, because I was just doing scaling
yeah.
in infrastructure. The big issue we would run into is that we were also trying to add features, and
Mhm.
so our ability to keep things up to date, like indexes up to date with new features, aging out indexes that were no longer used, but still taking a ton of memory up because all of our tables are growing like crazy. Um, but that was our big issue. When I talk about like get feed, you're constantly adding new queries in there and trying to play the whack-a-mole of new queries that are added. We never, I think at a fundamental level, ORM was not a problem. Like
Mhm.
we could see the queries at the end of the day in application logs. We'd log 1% of all queries, just period. And any query that took longer than, let's say, a second. So every single one of those was logged. God, I kill for ChatGPT these days to be able to just paste that shit in there. Oh my God. All of that is logged. And the ability for us to look at those and compare it to what we thought was coming from the RM was always exactly what we would expect.
Okay, that's interesting. So you didn't have any like ORM, like issues that kind of were brought to your attention. But like, let's kind of go back to sort of the story where, okay, you've successfully migrated over to Aurora. You fought all these fires with Redis and other limits that you're, you know, blazing this trail of glory. What was the thing that you forecasted that was going to break next with Postgres? Like you got through a couple of Dublins. Like, what was the next thing that like, you hit a bottleneck with?
Well, I mean, at the end of the day, there were only 15 read replicas. And so we were at 12. And you have this like really nerdy spreadsheet that has because the co-founder Rohan was really on top of this, or on top of me to do this, is like, we are going to double like next week. And I'd be like, yeah. And I want to take a moment to digress that like nobody understands, nobody's brain can comprehend exponential scale.
Yeah.
It's just not a comprehensible thing. It's impossible to comprehend that you are going to double in a week and a half. And not only that, so not only do you have to build something that'll double, you have to double, it's going to keep doubling. So for example, I said we doubled every week and a half from October 10th to basically mid-February. I think we hired, or late February, and I think we hired our second backend person beside me and Mo. We hired them in early February. So like our peak of traffic, we hired the second or third backend engineer like a week before we reached our peak of traffic. Like that's how crazy it can be. But you don't comprehend. And at one point, we were doubling so much, we're at 10 million weekly active users. Somebody did the math. And if we kept doubling at our current pace, that we would run out of people in the world in another 3 months. So it's like either we're going to run out of people in the world or it's going to end in 3 months. Either way. Like, this may be insane, but you cannot comprehend the exponential growth that you go through. You just can't, because your brain is so like, okay, if we just get this 10x better, but 10x better is like a few weeks. Like, it's just like your brain can't comprehend that it's just going to keep going. And it just did. And so we just have to sit there and be like, oh, we're at 14 read replicas during our peak. And in the next week, the next Friday, which is like our biggest day, or whatever day it was, you'd be like, well, we're going to need, if we're at 14, we're going to need 28, but we can only have 15. So you're like, that's just it. Like, that's the whole challenge right there is, that you're going to have all types of little small flare-ups. You're going to be talking to AWS about this issue or that issue. But at the end of the day, if your queries are so expensive that you're using so much compute that you need that many read replicas, there's no escape other than sitting there and burning down the list of your top queries. Like, that is it. And
So
we did that just,
and you're just like, we're about to hit a raw wall with this. We gotta like get the queries under control.
yeah, and we just sit like, it's not a very complicated process. It's just not fun. Like, you just take a query and you think, and I would just take queries and I'm like, I would just take a query and I would put it, I'd sit there on the ORM or on like the console, create an expensive version of that query, run it, see how slow it was. And then you would just sit there and try to tune it, like change the order of queries, like change the order of statements, and like try anything. Because sometimes you just change the statements, it makes a query cheaper. But it's impossible to explain it. Nobody could explain this stuff. But you'd sit there and do that. You'd sit there and like try changing an index. You'd try like, okay, maybe if we broke the query up, broke a join, and put it into two different queries to make it cheaper. But you just had to sit there and bang your head against the wall and try to find ways to make things less expensive and do it constantly. So there's only a couple of things you can do. You can remove queries, you can optimize queries, or you can cache them. And so it's like we did all types of janky caches everywhere you could look. You can only build two types of caches effectively. You can build a cache that's centralized or a cache that's per instance. And because of the way, like, some of our queries were so big that we couldn't even read and write them out of Redis fast enough. It was too slow. So we had to use local file system caches. So you would have 24 instances of these big fat servers. So you have 24 different caches. But it'd still be better.
Did you try changing anything with the mobile applications or stuff like that? Because I remember at Coinbase, and this happened at Facebook as well when I was working there. Like, you'd have like this really expensive query that would fetch loads of data on cold start with the applications, and like with Coinbase, especially like there'd be huge push notifications like that would like whenever an event was going on, it would like spike in price, people would join. Did you change anything from the application thing, or were you just solely focused on your end of the stack? I'm kind of just curious as a team how you guys came together to look
Yeah,
at.
actually, it's funny because when I was at Coinbase, I was one of the big people pushing because, like, every single time somebody opens the app and navigates around, if you're, they used to double up queries constantly. It'd be like,
Yes,
it'd pull transactions twice, it'd do this twice, or like they get a push notification, they load the app. Just all you need to do is fetch cached price endpoints. We don't need to pull their account data. It probably hasn't changed. Cache it in the app, please. And we would fight that battle nonstop at Coinbase because it was such a big deal. Like, for every single query, if you can cut queries in half from the mobile app, you cut your database queries in half.
Yeah.
So a lot of this is very obvious from my days at Coinbase, but I was shocked that I could never find an issue with the iOS guy, Daniel. Like, the code was clean. Like, what I do, my way of doing it is I put my app ID into our monitoring software and I navigate around the app.
Yeah, I could think of some ideas for that because I think like when and to be fair, Clubhouse was written a lot lighter than like the iOS applications that were used at like
Facebook. It was one person versus a whole team of people who have to add random features. Yeah. Like, oh, let me hook into that, but they don't realize that hooking into that makes another call. I'm not a mobile engineer.
Well, that's also as well, like it depends on like the ORM that you're using in the mobile clients, right? And a lot of those ORMs, they basically think of things in terms of, oh, it's the user class or whatever. And then underneath that, there's a whole mess of API calls that are being made. And so on cold start as well, you're fetching just a ton of data and like, in production and with like not a bull run going on, like that sounds like a great idea. But then you hit a bull run and you're like, okay, every time we send out, say, a price alert and like loads of people are like, oh my God, Bitcoin has gone up or gone down, you're going to have this massive spike of traffic. But I could kind of see, with a more modern application like Clubhouse where there'd be a more maybe thoughtful kind of like cold start process and that you wouldn't have that problem. But it's interesting to hear that like you guys didn't have you know, a bullet that you could kind of like shoot there. So that's kind of cool.
It's a bummer. Like there were times where you're like, you're looking for anything.
Yeah.
You're doubling every couple, week and a half, and you're looking for anything. And to not have it there when you thought you could, like, oh, we'll get to the mobile app later, and then you go and look and it's not there. That can be a bummer. But at the end of the day, it was nice to not have the issue. We still had the issue with sending hundreds of thousands of notifications and
Hmm.
seeing the spikes. And just as a random aside, like that is a crazy challenge. That is one of the hardest challenges I think in software today is sending real-time notifications to a lot of people. Like a price alert's a really hard one. And so you have to do really things that founders don't like is like you have to spread out the notifications
Yep.
and it makes the product experience worse. And so, but otherwise, if you send them all at once, actually, like you will actually take your app down because every single person will open the app at the same time. It was a weird thing because I think Coinbase and Clubhouse are like two of the only apps that had truly that really weird case where they're like, they want to send notice and they want as many people to come in at once. Coinbase got rid of the notice, which is really smart. They really wanted to hold on to those notices really hard for a long time, but they would take us down every single time,
Yep.
every single time.
Yeah, I've been there for a few of those. And I suppose, with Clubhouse, it's like if you got Paul and Mark Andreessen like lighting up a room, you're going to have a whole bunch of, different people coming there. Anyway, we're kind of coming up a little bit on time, and I want to kind of ask you a question, like, okay, so it's 2024, and like John Connor, you've traveled back in time, and you're, maybe it's not back in time, it's from an alternate dimension to Luke Demi that's kind of working on 2024 Clubhouse. What things have changed today, and would you use Postgres again if you were building from scratch and kind of like knowing that you're going to hit massive scale? What kind of messages would you pass on to like a version of yourself that's kind of building today? And is there anything that you would do differently, now?
Well, first I'd say, look, man, buy NVIDIA stock and quit your job. You don't need this stress. On a serious note, it's not really a fair question because of the fact that if you know you're going to reach scale, you would never use Postgres. You would
Ah,
build it. You would build it. You would build it with DynamoDB. Like we migrated almost everything to DynamoDB by the time I left. Like by the time, yeah, like it was all DynamoDB.
mhm.
DynamoDB is very deterministic almost. Like it's predictable. It's calls in, calls out. Like it's never had a mystery with DynamoDB. Never one. Well, Postgres they'd be every day. But that's why it's kind of a trick question because if you know you're going to have scale, you would build for scale. But I don't think anybody knew back then where we'd actually go to. And the ability to iterate really quickly, especially with tooling, is a lot easier with Postgres. And it can plausibly get to scale. I know that they're building a lot of really great, I don't know, what the actual like planet scale, like all these random things that are designed to
Neon,
like auto, what is it?
Neon is another one, and then there's
Neon.
Timescale has like a serverless thing, although it's not really serverless, and that's for time series data. But yeah, there's a few of those out there at the moment. Yeah.
And if you can shard inside of Postgres across multiple servers, that'd be sweet. I mean, it'd be challenging. Just give it. You'd still have to compromise on features. And DynamoDB had certainly its own share. It's a little more challenging, I think, for developers to get their head around, especially when they're like people get frustrated at this idea of having to think through like partition keys and all that and range keys. It's a little bit of like a mind mess, but yeah, I go back in time. I don't think I'd be able to convince myself to change tracks though, because at the end of the day, we were doing everything we could, and the idea of it depends on when you caught me, but at the time, there was just no time to do anything we wanted to do. Like you were keeping your head afloat,
Hmm.
period. And you were reaching out for all the help you could get. You were begging from the rooftops to find this is the feed to what you're selling here. He's like, we were looking for every single person who was an expert, anybody who
Yeah.
could help us. Because your pride is out the window. You don't care. You don't care how dumb you look. You're barely holding on. You just are praying. You're like, surely there's somebody smarter than me who wants my money right now. Like, surely. But then
We
it's
want
not
your money.
there. Yeah. But it's shocking. It was shocking to us that we're like, we don't care what it costs. We need somebody who's an expert who can help us get out of this. And we couldn't find it. We couldn't find it. And or they made you step through a lot of processes, or whatever. And you're just like, get on a call with us, please. Just get on a call with us. Look at these logs. Does this make sense that this query is so expensive? Like, why are we not finding this query? How can we monitor this better? There's a billion options in Postgres, and all of them are slightly like, for example, one of the biggest challenges we had is the fact that we just used integers for user IDs, and everything had to switch over to big int because we hit the limit of the number of users really quick. It happened first. It happened with rooms, then it happened every single table in the database. And so, how do you make that transition? It's actually really, really hard, and it's not something you'd want to have to do on your own because it's sketchy. Like what you have to do in the DB is sketchy, and we did end up finding someone who was helpful enough. But if we have time on the real interview, I'll tell you a story about our snow day, which is where the app went completely down. The app went completely down, couldn't do anything, and our consultant didn't answer the phone. So we were down trying everything. We actually had to build a whole new layer with feature flags to turn off routes one by one. We would turn the app off, the DB would go down. We turned back on, even 1% of users, the app would go down. And we built a query layer that basically allowed us to turn routes on one by one. We turn them on one by one, start B-treat it until we found the route that we had to leave that off until the DB consultant finally got up and answered our calls. He got on and was like, oh, it was a plan flip. You need to reset all of these statistics about what was wrong with that specific. I don't remember the exact details, but it was a plan flip. And because of how bad of a plan flip it was, as soon as that one query ran, it would blow up all the other queries to the point where it looked like they were all bad. It was impossible to segment exactly.
When you say plan flip, is a query planner flip? Is that kind of what you're referring to, or something like that?
So it was just.
What is a query plan flip?
It's like the database engine of Postgres does magic things, and the magic, it thinks it's doing something smart based on. I could probably give a more elegant answer on this in the future, but it's like at the end of the day, it thinks that the fastest way to do something is to use one index based on statistics of how what would be fast. It's analyzing how quickly something is, but it flipped and it decided it didn't want to use an index anymore. It didn't think the index was faster. It thought not using an index was faster than using the index due to the counters it has about how things are getting used. And it has its own little logic, and its logic was just completely busted. And boom, done.
How the fuck do you detect that? Is there logging or instrumentation of
No, it turns out no. You just
how did he know? How did the consultant know that it was a plan flip? Was it?
Well, he's like, I hear everything you've tried. Why don't we try this? Ran the query, ran the thing, and it was fine. I think what we ended up having to do is, I think it was a lot about, because we've run vacuums and analyze all these things. We've done it a bunch, but I think there is a lot to be said for wherever I wish I remembered exactly what it was, but we just did it a lot more frequently. Whatever the thing was that he recommended we do, we did it.
Well, we're at time. I'm going to stop recording.